Assalamualaikum and hi. We are from Group 6. We'll present about our mini project, which is production of maleic anhydride for BKC 3533 OSH in chemical industries. Now, I will explain about the introduction, background of the study. Okay, for your information, maleic anhydride is a multifunctional chemical intermediate with uses in almost every sector in chemical industry. So there are two main feedstocks that can produce a maleic anhydride, which are benzene and N-butane. Okay, for our project, we have chosen the N-butane to produce the product. Next is the application of maleic anhydride. In the production line, maleic anhydride is frequently utilized in the manufacturing of unsaturated polyester resins. If you can see from the figure in the slide, unsaturated polyester resins record a high percentage rather than other applications. There are several applications involve the maleic anhydride, which are agricultural chemicals, lube oil additives, fumaric acids, 1,4-butanol, and other. Okay, next, I will explain about the heads up for this project. There are two major units, which are reaction unit and separation unit. Okay, firstly is for reaction unit. The process is partial oxidation between N-butane and oxygen. The section is packed reactor. There are three process parameters that I had choose, which are flow, temperature, and pressure. So there are several guide words to explain about the process parameter. Okay, first is for flow. If the flow is less than the required, the pipe blockage will happen in the feed pipeline. So the possible consequences is less butane will produce for the reactions. So the action required to avoid this problem happen is to install low flow alarm at feed flow for operator to take action. Okay, secondly is for temperature. If the temperature is too high when handling the packed reactor, overheating from the heat released from the reaction. It means that the packed reactor will overheat. So the reaction will not operating on optimum condition. The action required to handle the problem is by install cooling water feed pipeline and high temperature alarm for operator to take action. Third is pressure. If high pressure is put inside the reactor, the reaction also will record on not optimum condition. To avoid that, we have to install relief valve and high pressure alarm for operator to take action. Next, second major unit, which is separation unit. The process is absorption of maleic anhydride involved in absorption tower. There are three process parameters: flow, pressure, and level. Okay, for this part, I will explain what will happen if the flow is less than the required. So, no control valve will respond to it, and pump of absorbent recycle stream fail to function properly, and clogging of product and waste flow. There are lots of problems will happen. So the possible consequences is the production will have incomplete absorption process. Product pipeline may crack and hazard to workers. Okay, the action required to avoid this thing happen is to install low flow alarm for operator to take action. Okay, the second is pressure. So if the pressure is too low, the absorber will fail to operate. So incomplete absorption of mixture will record. To avoid this happen, we have to install low pressure alarm for operator to take action. And lastly, for level, if the level is too low than the required, there will no level control valve, and incomplete absorption of mixture will happen. We have to install low level alarm for operator to take action. So what I can conclude from the hazard in these two units, um, we have to make sure that the alarm is functioned properly to operator to take action in whatever problems happened in the plant.
Hello and greetings. Let me introduce myself first. I am Govindaran Nilamalai with matrix number KA20136. I am now going to present about the faulty analysis of our project and emergency response team that we assigned for our project. Without delay, let's get into it. In this faulty analysis, this is the first part which shows a faulty diagram for a root problem where there is irregular pressure which is either high or low pressure in the reactor. This problem is predicted to be caused by two major reasons. First is faulty regulator pressure, which means there is a mechanical problem in the pressure regulator. If you look further, this fault is maybe the consequence of the regulator being too old, hence making it less efficient. The second reason for irregular pressure inside the reactor is caused by particles build up on the surface of packed bed. This will reduce the volume inside the reactor, and so that explains why the pressure increases. This event happens because of two subsequent events which are bad choice or unsuitable type of pack bed chosen, and the flushing process is not done on schedule. We can possibly solve this irregular pressure problem by replacing the old pressure regulator or choose the most suitable pack bed for the reactor, or by performing cleanup as per schedule. We move on to the second faulty diagram based on the fault present in the separator unit, which is absorption tower. The problem that we are talking is the irregular feed flow, which might be caused by first leaking from pipe and fitting due to usage of low quality pipe and fittings. Second, particles build up on pipe wall due to no flushing process done can also trigger feed flow program. Lastly, there might be a faulty flow regulator, which usually happens due to the aging factor of this equipment. Looking at possible solutions, we can use pipes and fitting with better quality to prevent corrosion, or perform cleanup of the system and replace the very old equipments to solve it out. I would like to bold it out that this analysis is made up of assumptions and predictions of possibilities, but there might be other causes too for being the reason for the main problem. In this part, let's look at our hierarchy structure of the emergency response team, which is led by the incident commander who mainly plans the best emergency plan, make sure good conditions of the equipments to be used, and also provides training to the team members. And then there is a vice incident commander who performs tasks requested by the leader, manage resources and funds, and mainly as a backup incident commander. A secretary at secondary level is to do the paperwork like reports and also to manage and make calls for arrangements. At the tertiary level, there is media and report team who collects media and data of incident and also manage communication platform for the team. The search and rescue team will find if there is any missing person in incident to be submitted to the medical support team who provide on-field medical aid and responsible to hand over the victims to the nearest hospitals. Fire control team will curb the fire breakout to prevent further events like explosion. And this team will closely work with the fire and rescue department of Malaysia. The technical team here is responsible to protect valuable machines and equipment from damage. And lastly, traffic control team will do crowd control at incident scene and assemble people at assembly point to check if there is any missing person. Each and every member in this hierarchy holds their specific responsibilities. That's all from me for now. Thank you so much for listening.
My name is Nur Shazana binti Suda, and now I will present the process description of the production of maleic anhydride. So production of maleic anhydride is the oxidation of butane that contain vanadium and phosphorus oxide as the catalyst. At the first stage, air is compressed to a moderate pressure using a centrifugal compressor. Then it is mixed with pure butane and feed to the packed bed reactor where butane react with oxygen to form maleic anhydride. So this oxidation is carried out at a range of temperature of 420 degrees Celsius and the reaction is exothermic. The reactor effluent is cooled and sent to the absorption tower where it's contacted with water to remove the light, gases, and all of the maleic anhydride react to form malic acid. The vapor effluent, which consists of non-condensable, must be sent to an afterburner to remove any carbon monoxide prior to venting to the atmosphere. Next, the liquid effluent is then cooled and flashed at a pressure of 101 kPa and at a range of temperature of 120 degrees Celsius in the flash vessel. For vapor effluent, it is sent to waste treatment, while the liquid effluent is sent to malic acid reactor, where it is broken down to malic anhydride and water. Next, the reactor effluent sent to the distillation column to separate malic anhydride and water. And lastly, the distillate is sent to waste treatment, while the bottom product will consist of 99% weight percent of malic anhydride.
Hi guys, I'm Surendran Vigneswaran. So I'm gonna explain to you guys about the next part of our project, which is the mass balance calculations. So before moving on to the calculations part, let me introduce to you guys what is mass balance. So what is mass balance? Mass balance is a balance to compare the input and the output of a certain process. Law of conservation of mass is applied to analyze the physical stream. What is law of conservation of mass? Law of conservation of mass states that the mass of a closed system will remain constant regardless of processes involving in a certain system. This statement defines that mass in is equals to mass out. So before moving on to the calculations part, we need to figure out the molecular weights of each and every substances. For example, butane, which is 58, oxygen, which is 32, malic anhydride, which is 93, carbon dioxide, which is 44, carbon monoxide, which is 28, water, which is 18, nitrogen, which is 28, and formic acid, which is 46, and also alkylic acid, which is 72. So guys, firstly, compressor. As you guys can see, the components in the stream 1 are the same as in the stream 3, which contains oxygen, nitrogen and water. And there is a mixer before the components in the stream 1 and 3 flowing into the stream 4. So let's look at the flow rates. For stream 2, the flow rate 1, which is 5130.9, and for stream 1 and stream 3, we need to apply the law of conservation of mass, which is inlet equals to outlet, which is F1 equals to F3, which will get 95129.14. And by that, we should also can calculate F1O2, F1N2, and also F1 for water. Same goes to reactor. To confirm the accuracy of the data and the inlet and outlet, mass have to be determined. So firstly, for reactor, we have calculated the R values, which is the R1, R2, R3 and R4 by using the given formula. So by using the given formula, we have calculated the selectivity. By calculating the selectivity, we have determined the R values. So the R1 value will be 61.93, R2 will be 9.0256, R3 will be 0.8848 and R4 will be 0.8847. So for stream 4, we will get the flow rate will be 100260.04, and for nitrogen for stream 4 will be 7512.152.02, for oxygen 18074.54, for butane 5130 kg per hour, and for water 1902.6 kg per hour. And the exact way goes to for stream 5. We have to do the component balance in order to find the flow rates for oxygen, butane, and also water, carbon monoxide, carbon dioxide, malic anhydride, formic acid, alkalic acid, and also nitrogen. So next up is the heat exchanger. As you guys can see from our PFD diagram, stream 5 and 6 both have the same purpose, which is to lower the temperature to 95 degrees Celsius. Flow rate 5 is equals to flow rate 6, as we are applying the principle of conservation of mass, which is mass in is equals to mass out. Same goes to the absorption tower. For stream 6, flow rate 6 is calculated by applying principle of conservation of mass, which is 100,260.04 kilogram per hour, and by that we can also calculate the flow rates of nitrogen, carbon monoxide, oxygen, carbon dioxide, butane, hydrogen, malic anhydride, formic acid, and also alkalic acid. Same goes to stream 7. We can calculate flow rate 7, which is 1902.58 kilogram per hour. For stream 8 is the same way. For flow rate 8, for F8 for stream 8, we get 85886.623 kilogram per hour. And we can calculate for nitrogen, carbon monoxide, oxygen, and also carbon dioxide. For stream 9 is also the same way. For stream 9, flow rate is 16275.60186 kilogram per hour. And by that we can calculate as well for the butane, water, formic acid, alkalic acid, and also malic anhydride. And lastly, we can add up flow rate 6, 7 equals to flow rate 8, 9 by applying the principle of conservation of mass, and we will get the same value. So it is proven that mass in is equals to mass out. So next up will be the second heat exchanger. As you guys can see from our PFD diagram, stream 9 and 10 have the same common functions, which is lowering the temperature to 40 degrees Celsius of a reaction. So for stream 10, F9 is equals to F10. By applying principle of conservation of mass, we will get 16275.60186. And by applying the common principle, we can also find out for butane, water, malic anhydride, formic acid, and also alkalic acid. And for flash vessel, it is also the same. F10 is equals to F11 and F12. So, but we need to make sure that all butane goes to wastewater treatment. We have to assume that first in order to solve our flow rates. For stream 11, we can get 842. We will be getting 842.085 kilogram per hour. And from that, we can also calculate for butane, water, and also all three acids. For stream 12 is also the same. The flow rate we're getting is 7847.5166 kilogram per hour. And we can also get for water, butane, and all three acids as well. But for the selectivity, we should assume that we should know that it's 1% selectivity for the malic anhydride, and also 1% selectivity for formic acid, and also alkalic acid, it's 99% selectivity. So lastly, F10 flow rate 10 is equals to flow rate stream 11. Adding on with flow rate stream 12, we will get the exact value. So it is proven that mass in is equals to mass out. Lastly, before going to the wastewater treatment, by applying the same principle of conservation of mass, flow rate stream 12 is equals to flow rate stream 13 plus with flow rate stream 14. But before that, before calculating for the flow rates of the streams, we have to make assumptions. What we need to assume that the top product contains 0.1% malic anhydride. 0.8% water, and 0.7% of alkylic acid and formic acid. We have to make sure that assumptions, because in order to find the flow rates of the streams. For stream 13, we will get 2071.730 kilogram per hour, and by that we can calculate for water and all three acids. For stream 14 is also the same. For stream 14, we can get the flow rate of 5775.59527 kilogram per hour, and we can also get water flow rate for water and all three acids. And lastly, by applying the same common principle of mass of conservation of mass, flow rate at stream 12 is equals to flow rate at stream 13 plus with flow rate at stream 14. We will get 7847.516, which is also equal to the, so it is proven that mass in is equals to mass out. Thank you guys.
Okay, now we discuss about the design plan layout. Okay, design plan layout is the arrangement of all facilities in the plant or the process plant or factory, including the machines, the work areas, the main buildings, and the service area. Okay, so before we start to design the plan layout of our process plant or factory, there are some factors that we need to be considered, including the employee safety and health, the amount of material that we need to be handled, the machine utilization, and the production transportation in the process plant. Okay. Well designed plant layout is very important because to ensure that the goal is achieved in producing a large amount of very good quality product. It also can reduce the handling costs, increase the employee morale and attitude, reduce the accident as well, and provide a safe working environment to the employees. Okay, now let's move to the safety system and feature. In our process plant, there are three safety systems that we will put together, including the fire sprinkler system, the emergency road, and the assembly point. The first safety system was featured is a fire sprinkler system. Okay. Fire sprinkler system is used to remove the fire or heat that can cause explosion in the process plant or factory. Okay. This system works because there is a high heat trigger the sprinkler system alarm. Okay. When the blast of fire ignites, the hot air will starting to rise and spread along the ceiling, which the sprinkler system alarm is located, and then the alarm system will automatically trigger, and the splash of water will be activated to put off the fire. Okay, so the water that goes out from the sprinkler system is pressurized water, which comes from the pump house. Okay, so the picture below, you can see that on the left side, the splash of water will be released from that bracket when the alarm is triggered to put off the fire. On the center, the picture at the center, we can see that there is a pipe, not a pipe, there's a pipe on the ceiling which release the water from the above, and then from the right side you can see that it is a pump house which release or provide water through the sprinkler system.
Okay, my name is Sasiruban, son of Ganesan. My matrix number is KA215. Emergency routes. So emergency routes are the direction that lead from one place to the next exit in the process plant. So the emergency routes are designed to be safer, faster and more practical way than other route to exit for any accident in the plant. It is crucial because it is a clear and safe way to exit the structure or building safely when there is an emergency. So the emergency routes are always clear of any blockages for the employees to evacuate the plant. So nextly, the assembly point. Assembly points are area of safety where all the employees should be assembled in an event of emergency. The purpose of making this area is to assemble everyone from the factory, workplace, process plant and ensure all of the employees are safe in the designated area when there is an emergency event. So I'm going to present a little about our design plant layout. So as you can see, there are two assembly points in our design, where one is on the left corner, bottom corner, and another one is on the middle. So as you can see, the arrows pointing towards the assembly points are the emergency routes, which the employees will follow to assemble at the assembly point in case of an emergency. So there's an emergency gate next to the assembly point, and there's another emergency gate beyond the car park, so the workers can exit the premises safely without having any injuries or complications. So that's all.
The first analysis being made was maleic anhydride is made from oxidation process of benzene and butane. As we know, these both raw materials are highly flammable. The whole process involves several units, and two major units are used, which are reactor unit and separator unit. There are a lot of processes to be carried out before producing the product, which also includes various equipments and machines working at dangerous level temperature and pressure. This maleic anhydride production is considered as a dangerous process, so risk assessment, hazard identification, and hazard prevention procedures are very crucial members of the planning. The report is made up of required elements of the production planning as per the rubrics, but there are still many elements must be considered for a chemical production plant. For the conclusion part, I will first mention about the objective of our research and project. The objective was to design and plan a maleic anhydride production plant which consists of elements of occupational safety and health, mainly related to the chemical industries. There was a report made, and it will consist of first a literature review and research on maleic anhydride and the production technologies used in the industries. Second, a detailed process flow diagram of all units with overall material balance of the production was constructed. Then, a hazard and operability study and a fault tree analysis constructed based on the reaction unit and the separation unit in the production planning. An emergency response team hierarchy structure was constructed based on the reaction unit and the separation unit in the production. And lastly, the report consists of an emergency response plan with a plan layout of the production plant. Here are some recommendations for chemical processing plant planning. Firstly, it is important to hire or consult safety engineers or Department of Occupational Safety and Health members for complete evaluation of risk and hazards. Secondly, design and plan the process and plant structure by giving priority to safety and health of whoever is involved in the production as well as to the environment. Follow all guidelines and rules set as they are made to provide safety and health. And lastly, do not rely fully on faulty analysis for risk assessment because it cannot predict all possible failures but only some of it. Allow me to end this presentation by reminding you about the iceberg theory of Don Brown, which says an incident is just the tip of iceberg and it's just a sign of much larger problem below the surface. Thank you for your time.